Analyst Alobis welcomes you all for the second day of IEEE FDP on Blooming Research Area under IoT, a 360-degree view, organized by GF Godavari College of Engineering, Jalgaon, in collaboration with St. Francis Institute of Technology and MH Sabo Siddiqui College of Engineering. So before we begin, I would like to convey the agenda of today's faculty development program. Today's program will have total 4 sessions from session number 4 to session number 7. Session number 4 is based on the topic of IoT, networking technologies and research challenges, which will be given by our eminent resource person, Mr. Rajesh Thakare. I would like to introduce our resource person, Mr. Rajesh Thakare. Mr. Rajesh Thakare has a total experience of 12 plus years and is the co-founder and CEO of Electrosoft system, where they provide the training towards industry, students, college staff, along with the development of various domain products. Mr. Rajesh Thakare has also worked in the domain of embedded system, robotics, artificial intelligence, IoT, and mechatronics. Mr. Rajesh Thakare has completed Master of Science in Electronics in North Maharashtra University, Jalgaon in 2010. He also has top skills in project management, research, and design area. Sir has also done different certification courses on various domains like Python for data science and AI for everyone, industrial IoT fundamentals on AWS, cyber threats and attack vectors, architecting smart IoT devices. Sir, I welcome you to this faculty development program and I request you to carry forward ahead. Sir, you can start with the session.
Yes, we can start it. Hello, I am audible. Good morning to everyone.
Yes, sir. Very
Hello,
good
ma'am.
morning, sir. Welcome, sir.
Okay, I am audible to all.
Yes, sir, you're
Okay,
Yes, sir.
audible.
okay. So welcome you all. Thanks for giving me opportunity to speak on this dais, booming research area under IoT. It's I think today's scenario. It's very important to talk about this. So more research should be required in this domain because India is now upgrading, and we know that all countries are working over the IoT, and parallelly we are also working with the USA and China like countries to make a very critical and complex devices with some standards. So that's why it's very important scenario to discuss on IoT. And it's a very good topic to cover 360-degree view. So all the students, all the researchers can understand the potential of IoT and the challenges of this domain. Okay, so I thought we have completed one day and it's our second day. So second day, I'm going to explain some of my details about IoT, networking technologies, and research challenges. I hope we can start the session. Before that, already ma'am has given my introduction, but still I will give you some my introduction. Uh, we have designed some number of products based on uh, different embedded kind of systems. Very basic, we have constructed onboard USB programmer for 8051 and the forward home automation over the Zigbee network it about 2012. And after that, we have created farm controlling over the GSM network uh, based on some message-based or IVRS calling kind of systems. So it's
Sir,
very
sir,
important.
sir, 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 sorry to interrupt you,
Hello.
sir. Are you sharing the
Yes.
screen, sir?
Yes, I'm sharing
It's
my
not
screen.
visible actually.
Okay, wait. Okay. Now it's visible.
Yes, sir. It's visible now.
Okay. Is it completely visible? Hello.
Yes, sir.
Yes, sir.
Yes.
It's completely visible. Okay.
Yes, sir.
Let me
Completely
further
visible.
this. Okay, no problem. Okay. I was there, farm motor control. After that, we have a little bit work on a pani puri vending machine, uh, which is very innovative. Based, we have tried for patent here. After that, we have done some mechatronics experience like CNC router and CNC thermocol machine, sanitary napkin vending machine, constantly. Uh, Next project is government-based dam emergency control. Many times floods comes and we have to inform to rest of the villages. So that's why we have constructed dam emergency. It's a real kind of project based on GSM module. Next, we constructed fence electrification and solar panel cleaning and the ROS robots now for the navigation and the IoT-based weather forecasting. This is what my introduction. Let's go towards today's agenda. We have to understand the IoT overview. IoT overview. Here I am going to just explain you some basic details. I know that all are know about this, but by my way, I am going to explain it to some details. Like IoT refers to a network of devices that are connected to the internet and can communicate with each other and with each other's systems. This device can range from simple sensors to complex machineries and equipment and can be used in a wide area applications for the home automations, industry applications. We know that even personalization can you use the IoT kind of devices. Simple architecture. It is what the diagram shows that it's very simple architecture of IoT. So though are the who are the beginner in this domain, they have to understand the simple structure of this scenario. So it's just first layer, the prediction layer. It's first layer where the sensors and actuators are connected. Those devices are very important who is giving the ground reality of the any kind of systems like say temperature monitoring or heartbeat monitoring for the personalization for the home. It's maybe a LPG gas detection for the industry. There are several kind of pressures and temperature many kind of end edge devices are in this bottom layer who is going to connect with the next layer which is network based on layer. So this layer responsible for the communication between the IoT devices and the cloud and the data center. That means it is the mid part between the upper layer and the lower layer. Lower layer is of end edge devices, sensors and actuators, and upper layer is kind of applications like where the control is going to be happen. So network layer is very important. We are going to discuss on this layer and further. Cloud layer. This layer is responsible for processing and analyzing the data calculated from the IoT devices. It may be used a range of technology such as big data analyst, machine learning, and artificial intelligence. These domains are very popular nowadays, big data analysis and machine learning, artificial intelligence. This is due to a number of devices connecting with the devices, like billions of devices. Recently, we know that we come with the pandemic like Corona, and we know that everyone is using some kind of medical equipment like proxy temperature sensor, uh, smartwatch. So those all devices are newly connecting through this internet connectivity. So that's why number of devices are going to connect over the internet. So traditional network is not going to handle this kind of devices. So that's why we need a cloud kind of environment to handle such a kind of big data. And the last is what even application layer, where the any person can control, any system can control the long over the distance devices. So these are three main blocks of your uh, IoT system. So let's take a one example where we can understand a little bit more clear uh, what we can do with. So I have scenario like I want to make light on off. We called it hello word program for IoT for the students when we teach how to do IoT. So it's my problem. I don't want to use mechanical switch to make LED light on off. So I'm going to on that lamp through the some network over the internet. So for this scenario, we have to proceed with some kind of a network. So that's why we have to connect this lamp with uh, some kind of hardware. We called it end edge hardware. So that hardware is a physical layer, consists with physical layer. The IoT system would include a light bulb connected to Wi-Fi enabled smart switch, which is itself connected to the internet. So that microcontroller is connected with your router. So it is also connected with your lamp. So it is creating connectivity to lamp with the network. So network layer comes in a picture, like router comes. So network layer comes in a picture. The router which would communicate with the cloud over the Wi-Fi using some protocols like HTTP and TCP. So based on this, you can construct one broker like client, so which can control that light through some application layer. So all the time we go with three kind of major parts. First is your physical layer, second is your network layer, third is your application layer. In the application layer, we are using some mobile kind of devices, mobile application, web-based dashboard, or we can send the request over the web page or mobile app to make that light on and off, so that push message to be MQTT broker will be sent to the that router, and that router going to control the microcontroller, and which sends device instruction to make it on and off. It's a simple scenario where we are going to control one light through some added network environment. So it's very simple thing that we have to understand. What the IoT it means. It is just an overview. It is what left side of the diagram it says about the traditional environment, and then second diagram with the right hand side where edge, fog, and cloud is introduced. This is what a modern educational diagram where we have to understand the edge, that means old kind of devices, fog where network devices, traditional network devices are not capable to collect such a kind of IoT billions of devices. So we have to connect fog kind of environment where the big data can be analyzed, and normal network cannot analyze such kind of data. So that's why we have to go with the fog. So fog will summarize the data, and it will send to cloud. So unnecessary data will not jump on a cloud. So it is what the additional layer in this system. Okay. We explain this new diagram where we have to understand the more details of these three layers, where we have to go with the access network layer. First lower layer, as I explained, that is a type of telecommunication network that connected to end user to their server provider. It is the part of the network that provides the last mile. That means connectivity between consumer and the service provider infrastructure. We have to understand the number of sensors and actuators and controllers we are using in this block, where home kind of devices like embedded devices can use the simple microcontroller boards, compact, low energy, low efficient kind of board. But in the industry where we have to use IIoT kind of PLC, SCADA, and long range kind of devices. So there are two different domains where we use consumer electronics and industrial electronics. So main point is in that physical layer, we are using some edge kind of devices where sensors, actuators, and maybe control devices, smart devices are the playing key role in that domain. So we have to understand this access network layer, which is we can call it a physical layer. So the next parameter, we understand the uh, second layer. We called it wireless access network, are the type of telecommunication network that use radio waves to provide connectivity between end user and their service provider. They can provide access to various kind of services, include voice, telephonic, internet access, and terminal media. So these layer also involved with the some wireless network like Wi-Fi. The diagram shows that the range of wide range of the sensors and their protocol. We have to know about the basic internal small range that we use for Bluetooth, BLE devices, Wi-Fi devices, and cellular network devices. Wi-Fi is a wireless technology that uses radio waves to provide high speed and internet. Then cellular network provides radio waves to provide wireless network over 2G, 3G, and 4G. Nowadays, we are going to install 5G. So due to 5G, there are faster connectivity between the low-end devices and the cloud-end devices. So we can overcome the bandwidth problem which we are facing in the 2D, 2G, 3G, and 4G. So next we can go for the like satellite networks. So satellite networks can be orbital satellite to provide wireless access again to a wide kind of data service. They provide over obtain use of a remote or a rural area where type of access network are not available. So where we are not covered with the GPS and cellular network area, so satellite network is very important to connect with those area. So it's very important aspects to understand with the satellite network. So next is we have to understand the network topologies. What are the network topologies coming in the network layer? Those are maybe multiple networks topologies. First kind of star topology. We all know about this basic what kind of star topology is, and then uh, topology, and then hello, hello. Okay, hello. I'm
Yes, sir.
audible. Okay,
Yes,
okay.
sir. Clearly,
Uh,
sir.
okay. Star topology. We are discussing about the star topology. All IoT devices are connected to a central hub or gateway devices. The hub acts on a central point. We are indicating that dark point is the central point and light points are low connected points which have not a more control. Center point dark, which is more connected and more control. The advantages of this topology is that it is easy to set up and manage, but it can less capable for the scale and number of devices. We cannot increase number of devices so that load cannot be distributed in a several ways. So mesh topology is there. IoT devices is can connect with the multiple devices using the forming a mesh network. This allows to reduce the path communication, which can be improve reliability and the scalability of the network. Like star topology has some issues. We can use mesh topology to overcome those problems. This is another way. There may be a number of topologies like burst topologies, ring topologies. We understand those on in a basic networks like hybrid topologies. With all these kind of network topology, we can construct uh, whatever we need kind of IoT kind of device. So this is a basic network understanding of the topologies. We have to know about the details, then gateways. Once we connect device with the physical layer, one temperature sensor, we make it smart with some controllers and connect it to the network. Then responsibility comes with the network is create a gateway for that sensor which can communicate with the upper application layer or cloud or maybe upper layer like maybe there are IoT, there are seven upper layers in the IoT. So we are talking about just three of bottom. Upper four layers are uh, like uh, I, like me maybe in IT case we are just doing OT case. So gateways and devices are used to connect IoT devices with the internet. They can act like a bridge between the device and network and provide functional search on a protocols, translation like data aggregation and security management. In many cases, gateways are used in IoT networks and enable communication between devices that use different communication protocols, have different data formats. We know that we are using different data formats. So you like uh, MQTT and HTTP. These all are different data type format to connect with the gateways. Then backhaul network, on the other hand, refers to the part of the network that connect the gateways to the cloud or data center. It is the network infrastructure that is used to transmit the data, collect from the IoT to the cloud processing, storage, and analysis. That whole network is typically a high bandwidth network that can handle large amount of data. So as we discussed, black hole is what uh, it's new for collecting number of devices. It's not traditional kind of network. It's very important. So gateway is playing very important role again, and additionally, backhaul network is creating IoT kind of structure to handle multiple kind of devices. So these this gateway and black holes is very important. So protocol transmission, data aggregation, and security management is the key role of these gateways. Then next is your network transportation subnet. In this layer, uh, we our objective is to convey all data on the network layer with the transportation system. So we use here some management sublayers like IP, TCP, and UDP, bring connectivity to IoT networks, upper layer protocols, and need to be share the data. So it's transmission between the smart devices and other systems protocol, like multiple protocols we use, where large number of data and devices can be handled. So we use their protocols, some like TCP and UDP. HTML and MQTT and uh, COP. These are the main resources where we discuss the transfer of data with these protocols. Uh, in a traditional way, we use HDP. So HDP is not capable to handle low kind of devices. It has no low memory structure and low bandwidth. so it cannot handle number of devices based on a IoT. So HTTP has some issues with their protocols. So that's why new innovation with the MQTT comes. Web sockets it often combined with the other protocols such as MQTT and handles the IoT specification parts, the communications. So that's why MQTT is important over the HTML. And next is again more advanced construction of this protocol is because HTTP is not capable, so they have constructed this to overcome the problems of HTTP, and it is constructing a uh, lower bandwidth environment, lower memory space required, lower bandwidth is required with this uh, new protocol. So these all are the network supported requested protocols. So we have to go towards fog layer. See, uh, in this image, in the left hand side, we have traditional traditional flow of data from the physical layer to network layer to application layer. In the right hand side, we are looking for the advanced diagram where we are connecting physical layer with the fog layer and then data center and then application layer. So in the fog layer, we are going to introduce new concept where data analysis and big data handling can be possible. The fog layer is distributed community architecture that is designed to extend cloud computing capability to the edge of the network. The fog layer is something also responsible for the edge devices. So edge devices can collect data and transfer to the fog layer. So fog layer can uh, collect all that data and it can nullify the error data and it can identify the important data through the garbage data and it can analyze through the several algorithms and it can sort out important data and it can send to the big data centers so where the data can be stored very smoothly. So basically important structure of IoT is with the 7 layer. So this picture comes with the full diagram of IoT network and the bottom layer as we discussed, which is physical layer, and the second layer we called it connectivity layer. Third is your controlling edge where we can consider as a fog connectivity with the data centers. So these three layers comes with the operational technology. This is what the new era we can understand that information technology works with the upper 4 layer and the bottom 3 layers are the operational technologies where now the research should be done. Then we have to discuss about the physical layer first. So where we are connecting the physical layer, we have to make some devices which is smart connected with the controller devices and maybe there are some actuators which is connected with those smart kind of devices. You can compute them with the some physical network. Maybe it may be a wireless network, it may be a wired network, but it should connect with some network so that they can provide all connectivity with the next layer. We call it network layer. Then this is what the second we called it network layer, where we are providing a number of components like communicating between the layers and devices. So it is providing us opportunity to make connection using some protocols and networks, gateways. So it's very important. Uh, it's a very important part to connect with the devices and the upper edge. So next is edge computing, where uh, edge computing layer is new layer where data package are processed in this IoT architecture refers to the computing devices that sit between the devices and the sensors and they collect data between the networks and the cloud. So in order to minimize minimize the latency of the network, it is very important to understand the edge computing layer. Several important function in the IoT architecture. First, it allows to local processing of data and the edge of the network, reduce the amount of data that needs to be sent to the cloud for processing. This can be help reduce the network connections and the low data transparency. In addition to this, the edge computing layer can provide real-time data analysis and designing making capabilities allow to rapid responsibility challenges conditions in this particular importance in application like industrial automation where delays are distributed in data processing can be having serious consequences. The edge computing layer may be also included specialized hardware and software components. So it's very these three parts of the main IoT network is important. Physical devices, second is network, and third is network computing. So we have to come on the challenges part where we have to understand about the new era challenges. There are several challenges associated with the implementation of IoT systems. Here are some key challenges we have discussed here. Uh, with that, security is the major aspect. IoT devices are often connected to the internet and can be easily easily penetrate, easily make by cyber attacks. Ensure that the security of the system is critical challenges, particular given to the potential for this attack have been serious consequences. We know that the mobiles are connected with nowadays with the all networks, and we are really facing the problems of cyber attacks. And now in the future, we are connecting all things. So those things are maybe controlled with the other hackers. So it's very difficult. In the last scenario, we have seen that in the Russia and Ukraine war, that most of the anonymous peoples have all the important documents of the Russian space agencies are on ground. So it's very difficult to manage this kind of security threat for the any entire country. So this is very important to handle with the every devices. Then next is our privacy. So there are every device which comes with some special privacy kind of systems. We know that our mobiles are very specialized device. It's very personal. So we have to keep the privacy of our data in the format of encryptions and we have to ensure that our data is processing with the some encryption which is very strong. It cannot break with the easy kind of decryption technique. So that's why privacy in the IoT kind of systems is very important. And the data management, we have to go with the several challenges like billions and trillions devices are connecting on the over the internet. So all devices are sending the data, and that data should be processed with critical kind of algorithm which can reduce the size of the data, and we have to even ensure the encryption techniques to manage the data. So this is again the challenging task to manage data in the next few years. Energy efficient devices. Energy efficient devices, that means there is again challenges for the physical layer and network layer where we have to construct devices who works on a low energy, low compatible, and it should connected with the internet all the time, and it should not drain battery all the time. So we have to construct such a kind of devices which can operate on a low protocol based, low energy efficient base. So it is very challenging task again. Then scalability. We know that in the next few years, right now we are in millions of devices connected over the internet. Within next uh, 10 years, we have to go for the billions of devices. So scalability of this system is going to be enhanced, and how the traditional network is going to handle this kind of integrity. So it is very important factor. We have to create such a new kind of system to handle billions and trillions of devices. So again, we have to define some standard for the particular network. So IoT domain itself have some standard, but uh, as we go for the protocols that are universally accepted, we have to go for the standards difficulty to can solve uh, in the next few years. So I hope my this presentation goes for the uh, uh, something beneficial for the new introductory students. So I hope if you have any query, you can ask me.
Participants, please ask the question, if any.
Okay. So
Hello, sir.
okay.
Rajesh, sir. Huh. At one time, how many nodes we can connect using IoT,
Okay.
and how to keep security, maintain security for it.
Okay, it's depend on the network what you are using. There are several kind of networks which providing use multiple nodes. For the introductory, we can use uh, like ThinkSpeak kind of network which provides us multiple devices to be connected with the cloud. And for the security, we have to again, I said that it's very challenging task to discuss about number of encryption techniques we have to involve into our protocols so your data can be secured. Generally, we have a number of open network protocol like HTTP and MPQ. So it's common protocol. It can be easily break. So you have to construct your own technique to encrypt your data and secure.
Okay, sir. Thank you, sir. Sir, one of the enthusiast participant is asking, Mr. Abhijit is asking whether you will suggest any research group working in this
Hmm.
area, any research group working in this area.
Yes, sir. Actually, there are a number of research area people are working. Right now, we are working on a IoT-based weather monitoring system where we are discussing about the government to set up a micro weather monitoring system to every ruler so that we can identify the uh, uh, like problem where the floods can come and then government or collector office is don't know about the weather situations of that ground level report. So we have to construct a very efficient device in the weather monitoring so it can provide a future data for the all rural areas.
Yes, sir. And how many groups are there in India who are dedicatedly working,
Basically on
particularly on IoT and cloud, with together?
uh, Uh, basically, in the our region, we are working with the some research and PhD holders who is constructing this weather monitoring device for the Jalgaon government.
Mm-hmm. Okay. Thank you, sir.
Okay.
Participants, please ask the question, if any. Okay.
Okay,
So, ma'am,
so
Mona Lisa, ma'am,
yes, yes.
please.
So as there is no questions ahead, we'll end this session with a vote of thanks. So thank you so much, Rajesh Thakare, sir, for your valuable informative inputs. We will surely consider this information and I hope all the participants will be benefited by it. Thank you, sir. Thank you for joining us.
Thank you. Thank you.
Yes, sir. Thank you very much, sir. Yes,
Okay.
Yeah. So I request
thank you.
all the participants to have 5 to 10 minutes break, and we will start another session by Mr. Ritesh Kumar at 11 a.m. So we'll have a short break of 5 minutes. Yes, Vijay sir.
Yes, yes, 5 minutes, ma'am. And please share the feedback link if you
Yes.
have uh, feedback link. Madam, I think this is the day two, session four, na? Feedback link.
Yeah, day two. I don't know actually. Feedback is not in my area.
Okay.
Yes, sir. Day 2, session 4.
Yes, yes, ma'am.